So this is Malware Freak Show 3. And I'm Nick, and this is Jibran. And so let's just jump right in. So instead of spending time on the agenda, we'll just skip right past that. The inspiration for this talk is basically something called System Intruder. And for those of you who are familiar with Bedroom Intruder, there was a parody created by this guy we know named Zach. And we were going to play the song right now, but since we're a little short on time, we're going to save it to the end, and we'll play it for you guys. So, brief introduction, who we are. I'm Nick Percoco. I run the SpiderLabs team at TrustWave. I started my career in the 90s doing InfoSec. Started out really doing penetration testing back then. This is my 4th DEFCON talk, and I have 2 more this weekend, one tomorrow and one on Sunday. It's a Droid talk and a mobile SSL talk as well. I'm also the primary author of TrustWave's Global Security Report. So if those of you are familiar with that, it's an interesting read.
Okay, and I am Jibran Ilyas. I am the Senior Forensic Investigator at SpiderLabs TrustWave. I have about 9 years of experience, and this is my only talk at DEFCON this year. I've spoken at Black Hat, Sector, and Source Barcelona before, and I happen to have a master's degree from Northwestern. So just wanted to brag about that.
So really, we want to talk about why give a freak show. So what is this talk all about? Well, we perform a lot of investigations on an annual basis. We go into a lot of environments where there's targeted malware, malware that's not taking off any bells and whistles from the AV engines that are installed in those environments. And we really wanted to be able to bring this to you, bring live demos to you guys, and be able to show you what sort of the state of the industry from a malware development standpoint looks like, and what the real criminals are using to exfiltrate valuable data out of corporations and other environments. Basically, the real big takeaway here that we see is, the exploit world is basically commoditized. The criminals are going after, they want to buy exploits, they want to be able to use those to get into environments, but they're really putting a lot of effort, a lot of development resources into developing malware. It's become a rather big business. They will put money into that industry. They will hire really highly skilled developers to make this malware for them. And just as if you have a business and you want to create a business piece of software, you may outsource it to some developers and build it to your specifications. They're doing the exact same thing. So really, what is this talk about? Well, this is the 3rd iteration of this talk. So has anybody seen any of the other Malware Freak shows before? Oh, so we got a handful of folks.
Yeah. We got frequent freak show points for you at the end, so just see us.
This is the 3rd iteration of this talk. 2009, we demoed a keystroke logger, a custom keystroke logger, a memory dumper, an early version of a memory dumper, and a video poker piece of malware, and then a network sniffer. Last year, we demoed another memory dumper, one that got a little bit more advanced. Some login credential stealers, a network sniffer again, and then a client-side piece of malware that basically targeted PDFs. It was a PDF attack. So this year we wanted to bring it a little bit more personal, bring it really home to ourselves and the people who are in the audience. And so we're really talking about some new targets. So this year we're talking about your grocery store, places you shop every day, your favorite bar, places where you like to get drunk, and your work, and then of course your smartphone. So this is all about you in this iteration of Malware Freak Show. So when we talk about sort of the evolution, so what have we been seeing? Now, when you talk about evolution, you typically will talk about 50, 100, thousands of years. But what we're talking about here is just 3. And we've seen a dramatic change in the piece of malware that we've been following, the malware authors, the malware that's being used in the various targets that we're talking about over the last just 3 years. I mean, when we first started following this and putting together this freak show, we saw sloppy malware developers. We saw people that were just literally testing the waters, trying to basically find ways to exfiltrate data, try to automate things that they were trying to do on a manual basis. But it was very very early on. They were also not being covert, so they were being blatant. We'd see things like networksniffer.exe installed in environments, or memorydumper.exe. I mean, they were very early on. And then also a lot of noisy output files. They would create these files that would be gigantic, especially when we're talking about the memory dumper world. Yeah. They would dump 2 gig files to the drives and literally just fill up the hard drives on the systems. And then they were easily detected. You just look at Task Manager in Windows and you can see them. They were blatant in front of you. In 2010, they started to get tricky with their file names. It wasn't anything that was super complex, but they were trying to change things to make it a little more difficult for administrators. And you got to think of a lot of the targets where these criminals are going after. We talked about your grocery store, your favorite bar. These aren't sophisticated IT environments. And so all they have to do is fly under the radar of the people who they're targeting. And they're doing a pretty good job of that. They were doing a pretty good job of that in 2010. They're also placing things inside system folders to make it a little bit more obscure. You know, if you place something in the root directory of a drive and you build up and you fill it up with a whole bunch of files, someone's may find that. The attackers found if they put it in the system32 directory, it's going to be a little bit more obscure. Not for most people in this room, but for the people that they're trying to target, the victims of the criminals who are targeting targeting people. And of course, the output was mainly in plain text. You'll see some things in 2011 and the stuff we're going to demo now, but mainly they're just putting plain text files. The data they're trying to exfiltrate was just written to disk. No major issues there. The advanced tools that they were using, basically advanced tools that we would use, could easily detect their activity. They were being a little bit more obscure. They may not show up in Task Manager, but we can detect them. And then automated exfiltration, that's sort of the key. If you're a criminal and you want to attack, say, 25, 30, 100 organizations, you're not going to manually connect to those organizations every single day and download the data. You want it to be automated. You want it to send the data to you. Just sit back, relax, watch TV, and collect all the data that you can out of these victim organizations. So then when we talk about 2011, so this is a little bit of a preview, so I'm not going to go into too much detail, but we talk about 2011, the malware developers have grown up. Either that or the criminals have decided to pay more money and hire better developers, because we saw some really interesting techniques this year. Some zero storage, so we're talking about them writing files to disk. We're going to show you some examples where there's literally the only footprint that's on the system is the piece of malware. There's no evidence of the data that they're actually handling and exfiltrating out of the system. And then where data is stored, they're using encryption to store that data on the system. And they're using more efficient methods. So you hire better developers, you can go, you stop having 500K executables and you get them down to just a few K, which makes things much more efficient and much easier to place on systems. And then, of course, automation. So automation's everywhere today. We just started seeing inklings of it in 2010, but now today it's basically automated everywhere in the system. So Jibran, do you want to take some specific pieces of malware, some of the evolution we've been seeing?
So, there are some folks that came to our 2009 and 2010 talks, and you guys might realize the notable features. So, like Nick mentioned earlier, 2009, it was just really basic. We were seeing keylogger.exe, networksniffer.exe. So they just didn't care. They knew that once they got into their organizations, they knew that organizations didn't have enough ID staff to even look at those executables. The FTP credentials were not packed in the binary, so we could just use strings and we could see all of the malware features, like, okay, what it does, where's the FTP, what is the FTP username, and the password. So lots of sloppy work. Output was just plaintext.cap files, so that kind of tells you that they really didn't care much. Then in 2010, they actually did one better. They started matching, svchost.exe. Anybody knows what that is? Okay. So basically, they just started naming their malware applications like legitimate Windows names. And then output was compressed and password protected. But again, the password was right in the binary. You would see something like rar-hp and then the password. So that was still pretty easy. Nightly auto-exfiltration appeared for the first time. I think one of the malware that we demoed last year had that. But the 2011, which I cannot wait to show you guys, you're going to have a ball watching these demos. So there's no output on the disk. Like some of the malware sniffers that you're going to see is that there's, malware takes the data in one hand, sends it out from the other. It basically has two buffers. It takes the data, it steals the data, and sends it out. And basically, it's a real-time exfiltration. And the exfiltration is no longer on like FTP ports or SMB ports. Exfiltration is on port 80, which, in a lot of even mature organizations, port 80 and 443 are allowed outbound. So the malware writers have realized that, and they fully, take advantage of that. Encryption and encoding of output data. That is like a really, really key feature trend in 2011. Before, us as forensic investigators, we would do disk analysis and we would search for, social security data or credit card data, and we would, just find it in the disk. There would be a file, and then we would track backwards. So now, when they're encrypting the data, those disk scans are useless because all the data that's stored on the disk is basically encrypted or encoded. So that was for the sniffers. The memory dumper, in 2009 we demoed the 3 executable files. And there was basically no anti-forensic capabilities, plain text output right on the root, system32 directory. 2010, single executable. It was a kernel rootkit, so they did get a little smarter, but the output was still in plain text. So, and the output was, if you had to sort the files, you would actually see the latest date on that output file. So you would still, it's pretty easy to detect still. Now 2011, it's the return of the 3 executable files. So it's like a full malware kit. One binary does something, the other binary does the second thing, and the third binary basically completes the package. And we're going to actually see that. And then everything is timestamped. So if you're looking for files in like system32, the most recently accessed or most recently modified, you won't get to see it because the malware writers first timestamp the binaries, and they match it with the system installation date. So, system32 directory has a lot of DLLs, right? So if they match those dates, you're probably not going to doubt those files. And last but not the least, that output, again, is encrypted. So you have to actually crack the encryption to figure out what kind of data they're exfiltrating.
So when we're talking about the malware landscape today, so this is more continuing on from 2011, so we're seeing some anti-forensic features being built into the malware. I think you just talked about the time-stomping component, but we see other features as well. And then, of course, the stolen data is encrypted. The encryption algorithms are getting more advanced. I think some of the early versions we just saw using like XOR to basically encode that data. But we're seeing things more sophisticated there as well. Mainly because if you're an attacker and you're going after a site and you're harvesting a whole bunch of data, even if you're storing it locally, you don't want someone else to come along and grab it and steal it from you. So might as well protect the data that you're stealing from those systems. And then of course malware as a DLL. We started seeing that. We're going to demo one of those as well for you. So now, like we've seen in previous years, we want to spend a great deal of time in this talk doing actual live demos for you. So I'm going to introduce each of these demos, and then Jibran's going to fire up and bring up his VM instance of each environment, and he's going to demo those live for you. So basically what we're talking about here, this is your grocery store. This is a place where all of us probably go to on a weekly basis, buy our milk, buy our butter, and buy our beer. And basically, this environment, this is where we see a piece of malware called Cameo. And we're not really sure why the attackers called it Cameo. We see it called Cameo over and over again in a lot of environments. But we gave this guy the code name Best Supporting Actor. Like Jibran talked about, this is a sniffer, and this is something that has very little visibility on the system itself. And so when you think about a grocery store environment, this is actually pretty sophisticated for some of these environments that we've seen, like the grocery stores and some of the retail environments. This is something that you don't really need to be that sophisticated to target a grocery store. I haven't been to a grocery store that has an IT security person hanging out in the back room. This is just check cashiers and the store manager. But we see environments where this malware is placed on either a central system in the environment or on all of the lanes. So when you're checking, you're buying your beer and they're scanning it and you hand them your credit card, they're swiping that, and literally in real time, your data is going from that register across the network out to the attacker systems, and they're then archiving that into a database and sorting it out for sale almost instantaneously.
Right. And part of the things to note is that the grocery stores, they don't, sometimes you won't even see Windows computers there. You would see the Ethernet, point of sale swipes, right? So obviously they don't have this malware is designed for a Windows box. So basically all the data that's going across on Ethernet to a server, in the manager's room, they want to place that malware there. So this malware has to be at the aggregation point of the data. So
with that, you want to bring up the demo?
Yeah, let's do it. Okay. All right, so this is the exciting part of the talk, and I think you all will enjoy it a great deal. So what we're going to do, obviously, we have 4 demos here, and have you guys been to a talk with demos before at DEFCON? We hear there's a very, very low percentages with the success of the demos. So, we're going to do a collective prayer to the demo gods. And we're going to do it before each demo. So I have an announcement. When I say what time is it, we all have to say demo time. So that will please the demo gods, all right? All right, and this room is packed, so I better hear like a huge cheer. And actually, we have an incentive for you guys. So whoever cheers the loudest, not only that we give a SpiderLabs t-shirt, but also a pass to our party.
That's right.
Yep. Awesome. So you did it the first time. There are 4 times, so you better make sure, or better be awake. Because, all right, so are you guys ready? All right. What time is it? There you go. You guys are good in the first time. That's exciting. I think we're going to have a lot of fun. All right, so as I said, this is a grocery store, right? Does it look like a grocery store? Do you see your common things? That's awesome. Okay, so first I want to show you the binary. So the binary is called cameo.exe. I'm going to show you the size. This is only a 24 kilobyte binary. And if you mouse over this, you see keyword sniffer, MFC applications. That kind of tells me that this is probably like an off-the-shelf product, but they modified the code, and then they made it so that it has some anti-forensic features. So what I'm going to do is copy this binary to the Windows System 32 folder. That's typically where a lot of the malware run from, right? So, and then we're going to start the command prompt and actually browse to that directory. Everyone following me so far? Awesome, cool. All right, so I'm going to start, so basically to run, to install this malware, you basically just type the malware name. The malware writers, they actually code it so that it's installed as a Windows service. Can anybody tell me what's the advantage of being installed as a Windows service? Yeah, so when you reboot the system, the malware comes back. So here you go. I'm going to start cameo.exe. Notice we didn't see anything. The malware is running. So what I want to do now is actually show you. You guys familiar with Procmon? It's a sysinternal tools that kind of monitors the activities of a process. So I'm going to say that, hey, I only want to monitor whatever cameo.exe is doing. Hit apply, and this is basically it. So as you can see, the malware is running, but it's not. It doesn't have any disk activity at this point. So I also want to start my Wireshark because remember I told you that this malware actually sends the data outbound on port 80. So we want to see what data actually goes out of the network, right? Okay. So even at Wireshark, I don't want to monitor the whole network, the whole grocery store, right? So I want to just filter for everything that's going out on port 80. Anybody know a filter that we can feed it to Wireshark that just gives us port 80 traffic? TCP.port, yep, equals 80, right? So that's what we're going to do. We're going to say, okay, you know what, you're sniffing, this is me sniffing the traffic to figure out what the malware actually sends out. So I only have one interface, so that's easy. And then I'm going to say TCP.port equal 80. So now the sniffer is only going to show us what goes out on port 80. All right, so now that we have our sniffer set, I'm going to jump to my host machine and actually show you a file with the credit card data. So that file is basically called check3.txt. So as you can see, there's not only just credit card data, but what we call credit card track data, the magnetic stripe data on the back of your credit card. So why this is useful is because if you steal someone's track data, the magnetic stripe data, what you can do is you can code that on your credit card. And then wherever you go, let's say you go to a Best Buy or whatever expensive place, you can buy like a $5,000 plasma TV and they'll ask you, hey, show me your ID. So on the front of the card, it's your name, but behind the scenes, this poor victim is going to get charged. So this is the file that I'm going to send on the network, and this is the file that the malware is going to intercept. So I'm going to log into the FTP server there. So I'm going to send the data on FTP server, and then we're going to see the data go out on port 80. All right?
Yeah, so this is very similar to what you see in a grocery store when you swipe a card at a lane in a hardware terminal. It's sending that data to a central processing server. So that's basically what Jibran is going to simulate here.
Yep. So I'm basically feeding the data to that aggregation point, right? And this happens for all of those, grocery shop terminals. So I'm going to say check3.txt, just put it there. And then we're going to go back to our screen here and go back to Wireshark. And voila, that worked. So the demo gods have answered. So we have this severe-looking traffic, right? Some traffic is going to this FDM.php. So right now our attacker server is the internal IP because we didn't want to send the data out, even the test data. So this is basically the packet that we're going to follow and see what the output looks like. So I do a right-click on it, and I go follow TCP stream. So this is basically the packet. As you can see, it's a post, and the user agent is Cameo. It's sending it to this IP address. Notice it's an internal IP, but in the real world, there would be an external IP, like in some Eastern European country that I should not name. Content length, and then this is the data that's going out. So can you see anything? Can you make anything out of this data? Okay, thankfully not. All right, so I'm going to copy this output. So this is basically the data that's going to the attacker server. So how do we crack this? So we basically, at SpiderLabs, our researchers crack the code, and we're going to see how this data looks like. So I'm going to go to my Cameo directory, create a new file called malware output, right? And basically paste the information that I saw in the TCP stream. Okay? And what I'm going to do now is basically copy a script. It's basically a Perl script called Cameo Decoder. Put it here and browse to this directory. Okay. So the way to run it is you basically do cameodecoder.pl. That's the Perl script that we wrote to crack that data. And I'm going to feed the malware output.txt. So that's the file that had the encoded data. And then I'm going to say, can you please put all that data in decrypted data.txt? Okay, so the script runs and it basically decrypts the data. Now we have this file that has the encoded data. And now we open the decrypted data, and what do you see here? It's got an IP, source port, then it has that full credit card number, actually magnetic stripe data that we saw earlier. Got it? So that's how sophisticated the malwares are getting. As you can see, there's no storage on the disk. It basically takes the data on one buffer, and then every 30 seconds it sees, hey, is there data on my right hand? If there is, then I'm going to send it from my left hand. So it's kind of like charity, you know. Yeah, so that's it for the Cameo malware. I'm going to turn it over to Nick Percoco, and he's going to show you about the second malware. All right, so before we do that, I'm going to set up my snapshot.
Okay, you bring up the presentation.
Yeah.
Okay, so let's go into the, there we go. Okay, so the next piece of malware that we're going to show you, this is targeting your favorite bar. So obviously, I would think everybody here has been to a bar before, and when you go and you buy a beer, or you start up a tab, you hand your credit card to somebody, and basically your card is being entered into a system, and then it's being processed, similar to what we saw in the grocery store, but that's happening in a bar. And so the type of malware here is different. This is not a network sniffer. This is a memory dumper, and then the memory dumpers are designed to obtain data while it's in memory, as the name sort of tells you. But the big key factor there is that we see this being used in environments where data is being encrypted to a system. It's being encrypted while the data is on disk in the system by design, and then it's being encrypted while it's being sent to, say, an upstream processor or an upstream system. So the criminals sort of scratched their heads for a little while and thought, how are we going to get access to this information? And they started developing a memory dumper. And so we call this memory dumper the son of brain drain, because last year I think we demoed brain drain. This one's a little bit more advanced. Yeah. And so to not steal any Jibran's thunder talking about the key features, I think are you up and ready to go for the next demo?
Yeah, sure.
So you want to do your chant?
All right. So the demo gods were very, very, very happy. I just got a message. So we're going to do this again, but this time we're going to do one better, right? We're going to raise our hands and say demo time when I chant. What time is it? You guys look fantastic. Thank you so much. All right, so we're going to start the same way. I'm going to show you the binaries. So this is the memory dumper malware kit. So as I mentioned that, you know what, they have multiple binaries doing the job. So let's see what each of them looks like. There is winboot.exe. So this is basically the controller. This is like the master malware, I would like to call it. So this is the one that gets installed as a Windows service, and we already discussed what Windows service does to the malware. It comes back every time system boots up. And when it runs, basically the only job that this malware, this piece of executable has is basically starting the two other binaries. So this first binary that you see, csrsvc.exe, that has a list of executable names that are known executables that handle credit card data. So it has the name of the most common point of sale applications. So when you go to a restaurant, you go to a hotel, you go to a bar, you see a typical kind of systems. I don't want to name any of those software, but the attackers know about all of them. At least all the popular ones. So they basically say, hey, you know what, rather than dumping the memory of like 4 gigabytes of the whole computer, we don't want to create that much noise. So what we're going to do is pick those processes and just dump the memory for those particular processes. So the footprint is less, and then they delete that dump too after they parse the data out of it. So the CSR-SVC, again, it dumps the memory of a particular process. This last piece, inetmgr, that is the piece that actually looks at the dump. So if a dump is 500 megabyte, attackers don't want to transfer 500 megabytes because, guess what? At a grocery store or a bar, the bandwidth is not that awesome. So they don't want 500 megs of data coming for like 4 credit cards. So what they do is they write this application, which is like a Perl application. They've converted it to exe with Perl 2 exe. And this piece actually looks at the dump files, and it parses out only track data. And then this is the piece that actually does the encryption and some other features, which I'm going to show in a minute. So without further ado, we're going to run this memory dumper malware. OK, so see these files, winboot.exe. So this is winboot.exe. So basically, the malware writers, they actually followed a lot of good coding skills. So the installation for this malware is basically an install switch. winboot.exe/install. And guess what you see? Windows bootloader installed. You know what? I want to show you something really cool, which I love about these malware writers. They try to freak you out. So what you're going to see when you see the service, Windows boot, yeah, so this is the one. So as you can see, the path to the executable is the path that we were in, winboot.exe. And guess what it says? It manages the loading of the Microsoft Windows operating system, right? And better yet, if this service is disabled, the Microsoft Windows operating system will fail to start. So, this is the first year that they've got all the spellings right. They usually mess up on the spellings. So it's a huge year for those writers here. OK, so now that this malware is installed as a service, we have to run this. As I said, they wrote the code brilliantly. They also have a debug feature to this. So I think someone was queuing their code. All right, so we're going to run this in debug mode. And what you're going to see here is basically, these two pieces haven't started yet, right? So when I run it in debug mode, there's going to be 2 new processes. And you're going to see that right on the system tray here. All right, so winboot.exe, hey, I want to see debug. So now, as you can see, there's a new process, csrsvc, and also the inetmgr. Right? So I don't know if you could see it that far. It's saying, basically it says state loading, please wait, state monitoring. So the malware is kind of saying, okay, you know what, I'm ready to do the dirty work, but you got to do something for me to do anything. So right now the malware is just sitting idle. I mean, it's monitoring, but it's not showing any output because we haven't processed any of the sensitive data. So as soon as we do that, you should see something here. Okay, so I need a volunteer here who's going to come to our bar. And as you can see, we have a pretty cool bar, the whiskey bar. So who wants to come to the whiskey bar? There you go. We got a brave soul here.
Yeah, come on up.
Okay, so while he's coming, because this is not a point of sale application, we don't have a payment processing application here. So we're gonna trick the system. We're gonna say, let textpad be our payment application. So instead of textpad.exe, I'm gonna say become pbtsrv.exe. So textpad is our payment application. So I'm gonna open this. And now I'm going to ask our volunteer to actually swipe a card. Actually, what kind of beer would you like? This is a bar, so.
Bud Light.
Bud Light.
So he wants Bud Light, and sorry I couldn't provide a cuter bartender, but. Okay, swipe the card. Yeah, there you go. I'll help you out. Okay, so I want to show you that this guy wants a lot of beer.
Want a real?
You want to use the real one?
No.
Well, this is a gift card, so.
This is a gift card? Okay.
Okay.
Sure. Go for it.
There you go.
All right. There we go. What does it say?
A gift for you.
A gift for you. Awesome. Okay. There you go. So thank you very much. We don't have Bud Light today, but we still want to.
Here you go. You get a T-shirt.
So you get the T-shirt. Thank you so much for volunteering. Okay. So now we have got this data. Obviously, PBT serve. Now if we watch these processes, it says, hey, can anybody read it? It says, hey, in this memdump folder, there is a dump file. And in that dump file, I found track1 data. All right? So we're going to go to our folder, which has, so now notice there are two new things here, memdump and inetinfo. See that? Okay. So one thing I want to show you, this is a really, really key feature. inetinfo is actually the malware output file. But notice that the time on it is June 1st, 2005. Right? And not only the modified time, but the create time is also June 1st, 2005. So if you're looking for more recent changes to your system, you're not going to detect this file, right? Because and basically we just wrote data to it. So as we modified, we didn't see anything here. So let's actually check this out, the data in this file. I'm going to open it with Notepad. And guess what you see? Garbage. It's just, that data is encrypted. So what I'm going to do is go to my SpiderLabs script files and basically show the desktop. So I'm going to run the decryptor. Oh. Got them all selected. Okay. Well, there we go. Freak tools, maybe? Yeah, there you go. SpiderLabs, iNet decrypt. And I'm going to copy that to memory dumper. All right. So, okay. So this is my script that's going to decrypt the data that we saw. And let's say that I want to feed inetinfo.chm file, and then the output output file, the name I'm going to give is decrypted data.txt. Okay? So let's see what decrypted data has. So basically, that's how neat the output is. It basically says memdump pbtsrv.exe 2992, that's the process ID. And actually, you know what? I'm going to open it for a better viewing. There you go. All right. So basically, it's not the hacker saying TrustWave SpiderLabs 2001. That's our script, and memdump, and then the pbtsrv.exe 2992. Mr. John Smith's credit card is here. Not only track1 data, but track2 data as well. So that's about it for the memory dumper malware, and we're going to move on to the next one.
Okay. And when you talk about these hitting you personally, I actually once got a call from Jibran, who asked, "Were you at this club in Las Vegas last July? And is your credit card end in these 4 digits?" And I said, "Well, why?" And he said, "Well, you probably should need to call your credit card company. Your credit card was exposed in this breach." So that does happen from time to time. So The next one we have here, and I think we're running a little short on time, so we have two different demos that are remaining. We have this web check DLL, and this is basically targeting your work, and this is where this is basically an example of how you hear about critical files being exposed when corporations are having data leakage problems. This is a piece of malware that actually will attack that and gain access to it. So we have that demo, and then we also have a mobile demo.
And I think the mobile one is pretty short. We can show you that demo in 3 minutes. But this malware is pretty malware because it only has a DLL file. So notice when we mentioned that a DLL can do a lot of damage, you're going to see that here. So let me show you the malware. It's called the web check DLL. Basically, you can install this malware with a simple registry hack. You can, and I'm going to show you what this registry file has. So this is basically the folder in the registry that it tries to modify. And so I'm going to do it manually so you guys get to see it. So what I want to show you here is that the name of the malware is webcheck.dll, which is also a legitimate Microsoft file. So, if you mouse over that, you basically see website monitor, and it's only 10 KB. So local machine software, I'm going to find this registry key. Okay. So basically the legitimate file, Windows Explorer, whenever it runs, it basically loads this file, webcheck.dll, but it loads it from system32 folder. What we're going to do is we're going to paste, copy and paste this file in the Windows folder, and we're going to tell the system to run this file out of Windows folder rather than Windows system32 folder. So it's a pretty simple hack. I just placed a file here, and so this is the legitimate file. So I'm going to tell the system to basically do, load the webcheck.dll, but from the Windows folder. So obviously, if you had time, we would have restarted the system and showed you, but I think the quick hack I could show you is if we just if we end Explorer and reload Explorer, it should work. If it doesn't, we have to cheer louder. Okay. So basically now when Explorer.exe has started, notice we did the hack. So now Explorer.exe has to load webcheck.dll from Windows folder, so the malicious one. Basically, this malware stores the data in the root of the drive, but it has the hidden attributes, not just the hidden attributes, but also the system attributes. So we have to uncheck this button, which again is a Windows no-no. So notice you have this file, page file. What's page file in a Windows system? Virtual memory, right? So you're going to see an additional file if everything goes right. So we're going to go to our company intranet, right? And it says intranet.mycompany.com. And we're going to try to log into this folder. John Smith, and then I'm going to type in my password. And it sends me to the intranet folder. So in the confidential folder, I'm going to upload a file. And that file, basically, you do a lot of activity from your browser, right? So basically, this malware is targeting your browser. So anything that you're doing in the browser, better watch out because it's trying to steal that. So I'm going to put this document there. So let me show you the contents of this document. It basically has some confidential information. It says, President arrives at DEFCON on August 5, will attend Spider's party. So we're going to process that to the browser, right? I'm going to upload this file and then go back to my C drive. Do you see page file there? Basically 18K. So right now it's not exfiltrating any data because the malware writers have coded in the malware itself the time to exfiltrate data. So I'm running a local FTP server. We've kind of passed a malware so that it sends the data to an FTP server, but I'm running it on the local host. So this is where you should see data around 2 a.m. So I'm going to change the time to 1:59:50 a.m. so that we get 10 seconds to pray. And basically the minute it hits 2 o'clock, we should see something. Okay, it worked! Awesome. Okay. So we have this file now. Notice the page file disappeared. Now it's only page. The page file is going to come back, but in the meantime, there's a zip file here. So we should be able to extract this file here, right? So we say extract. It says, hey, no archives found. You're a sucker because this file is not a zip file. All right. So basically, what I'm going to do is copy this file, and I'm going to go to my Ruby folder because that's where we wrote the code. And okay. And this is basically the decryption script. So I'm going to put it in the bin folder, and pretty quickly I am going to run this so you guys actually get to see the data before we have to leave. All right, so see ruby.in. So I'm going to say ruby decrypt this, and the data is like, I think it starts with a C or something, right? Ruby.bin C29. Okay. There we go. And I'm going to say decrypted data again, decrypted.txt. Okay, so the script runs, it tries to decrypt that data, and then we go back to the same folder to actually check that, and here we go. So no, what was the key word in that file that we can look for? So basically here, you see a file upload, but all that data malware basically captured. And you can't open this file. Even if you wanted to open this in TextPad, you would see garbage. So you basically have to write a decryptor to actually see any sort of data. So just imagine like what we do in our browsers. We pretty much do everything in our browser. And if the malware is only 10 KB and can take stuff from the browser, it's pretty cool. Okay. I'll let you know. When you get this T-shirt, I'll let you know. It's pretty, okay. So I think we're going to wrap up.
It'll be over in pavilion number 4 for the Q&A session.
Yeah, so pavilion number 4 will be in the Q&A session. We may be able to show you some of the last pieces of the demo during the Q&A time. Yeah, we have a mobile malware demo as well that we're trying to fit into this presentation. Yeah. So basically, we're done, and basically the closing things here is next year we predict a lot of new, more advanced activities. And thanks for coming.
All right, thank you.